All right, last time we introduced the concept of a contract and then showed how you could use a contract to prevent a program from succeeding but in a strange way that you didn't expect. So in this case, if we didn't have this line, if I got an integer in here, this would double the integer rather than concatenating the two strings. So here I make sure that I've got a string. We also looked at the case of a z-index, which is stored as a string in the DOM API. So if we tried to increment it by adding 1 to it, it would simply concatenate a 1 onto the end of the string, which isn't what we wanted. Kind of the reverse of this problem I just illustrated. So once we have contracts, you can write functions that use them. And we call a function that has a contract on the input or the output a guarded function. Now, since we can write this simple contract, probably the simplest one there is, that never throws an exception, we can say that every function is a guarded function. It's just guarded by any. Now these two different pieces, this contracts and the functions they guard, form what is called a category. And category theory is all about the different kinds of categories that you find in math and maps between categories that are called functors, and maps between functors that are called natural transformations. And all of this turns up in the way we write programs, though not quite as explicitly in some languages as in others. So I'm going to be explicit about how these various concepts turn up. So again, what we have is contracts and guarded functions. Together form a category. Now if you read about category theory, they'll call the two parts of a category objects and morphisms. Now this is kind of an unfortunate jargon collision of terminology, because objects in categories are not quite the same thing as objects in object-oriented programming. They are related to each other, but in a very special, almost subtle way. And I'll get to that relation later. But the objects of our category are the contracts, and the morphisms of our category are guarded functions. Since every function has an input and an output, we say that this guarded function is from strings to strings. Given any two contracts, there's a set of guarded functions that accepts as input values that pass the first contract and produce values that pass the second contract. If it's not otherwise specified, the guarded function goes from any to any. So let's look at a couple more contracts. Right here we've used the type of operator to pick out strings. We can generalize this to pick out any of the 5 primitive JavaScript types. So let's make a copy of this, modify it to give us a contract for each of the primitive types. So I'm going to call this type of, and it will be a function that returns a contract given the name of the primitive type. We expect type to be a string, so we make sure that that is true. Then we return the contract. Let's call this P for parameter instead of S for string, just so that we can maintain some mnemonic reminders here. So if the type is not the expected one, then do this. Otherwise, we return the parameter itself. So now we can declare Boolean equals type of object Actually, let's shorten this a bit. Var num type of number var undef equals of undefined. So now we have the 4 other primitive types as contracts, and we can consider functions that map from one type to another type. So we can write something like var increment x, and then say I want x to be a number x, and we return num x plus 1. Now, increment is a guarded function that takes in a number and spits out a number. Now in this case, putting the num contract here is overkill. We know that when we add 1 to a number, it has to be a number. But if we're doing more complicated things in between the input and the output, it's helpful to make sure that we're putting out what we should. Particularly since if the exception is thrown here, we know it's the fault of this function. If the exception is thrown here, we know it's the fault of the caller. So this also helps us figure out where to assign blame.